Okay, everybody. Today I'm going to present you with an audio test set which I have built in the early 80s and it's still working until now. It's a very nice instrument. Um, it's a must in the audio world. So it has a lot of measurements in the audio field. It is composed from 3 different instruments. This is a variable signal oscillator, very low distortion, a millivoltmeter, and a distortion bridge. It also includes a 1 kHz filter, an A-weighted filter, and a low-cut filter. With this instrument you can do a lot of measurements. You can do a frequency response, you can do power measurements, you can measure power in watts RMS, you can measure distortion, you can measure noise, you can measure crosstalk, and you can measure, of course, levels. Okay. The signal generator has a range of 15 to 170 kilohertz, which is totally linear, very good linearity, in frequency as well as in level. The millivoltmeter starts from 0.03 millivolts, 0.3 millivolts, which is minus 70 dBm, to 30 volts, which is 30 dBm. Of course, the distortion bridge can only measure distortion on 1 kilohertz. The 1 kilohertz filter here, it is to measure crosstalk between 2 channels, left and right. The A-weighted is for noise measurement. It mimics the human ear. And the low-cut filter is to remove hum from a measurement in order to have a more precise measurement. In the meantime, you can have a scope output so that you can see the waveforms on the scope, and you have an oscillator output and a millivoltmeter input. I'm now going to open the top cover so that you can see the inside. Okay, what have we got here? This area here is a audio oscillator, the variable frequency oscillator. This area here is the millivoltmeter. The board on the bottom with this area is the distortion bridge. This little board here is the 1 kilohertz filter, the power supply at the back, and we've got an audio amplifier here so you can listen to the measured signals. It is all unbalanced, but in case you need to balance it up, you can use external transformers so that you can have balanced in and balanced out. What we'll do now is we shall mimic a measurement. So what I will do, I will connect the output of the signal generator to the input of the millivoltmeter. What you hear now is a 1 kilohertz signal, and you can change its frequency by rotating the frequency knob. You see that? Whichever frequency you choose, the needle stays the same place. Now that's a low frequency. It's 15 to 150, 170 hertz. This is 150 to 1.7 kilohertz. This is 1.5 to 17. Of course, you can't hear it anymore, and that's the highest range of frequencies. Now what we'll do is we'll drop by 10 dBs the signal of the oscillator, and we increase the sensitivity of the millivoltmeter, and as you see, it stays always the same place. This is what we considered a linear. There is a bit of a change there for some reason. Come on. It's quite old now, but still works. I'm really happy with it. We've done lots of work with this instrument. Okay, what else can we do? We can always test the distortion. For that case, we test itself. What you have to do is to set the instrument to maximum signal, and then you read it, and why it's not doing it? They waited. Yeah. Okay. Sorry. We made a mistake. It is only on 1 kilohertz, so okay. Start again. Reading it. By adjusting the bridge, you try to obtain the best null. You increase more the sensitivity. It's getting very touchy now. We missed it. Anyway, it's not really important. It takes time to obtain the best distortion reading, so we leave it for another time. That instrument, thank you very much.